Hey guys, section 7.6, we're going to solve some exponential and logarithmic equations. So this is kind of a nice section because it's just solving equations. That's it. So I think people normally do pretty good at this. So let's kind of go through some. Alright. Number one, solve by equating exponents. When you have an equation, and you could get these two things to the same base. Like there's a property in the beginning of this lesson that says b to the x is equal to b to the y. So notice they're the same base. If it's some number to the x equals some number to y, then x would have to equal y, right? I mean, if this was x squared equals x to the, x. Yeah, that's confusing. This, since they're the same base, x and x, this would have to equal this. So that's why we'd say, oh, x would have to equal, this would have to equal 2. That looks a little confusing, but you get the idea, right? So that's what we want to try to do. We want to try to get these two bases. This base is 4. This base is 1/2. We can get those to the same base. What does 4 and 1/2 have in common? 2. 4 is 2 squared, right? So that's 4 to the power of x. So 4 to the power of x. There you go. Equals. I want to get them both to 2. So 1/2 is the same as 2 to the negative 1. Alright? Hopefully it's not hard for you to think about. 1/2, 2 to the negative 1. To the, now this is where it gets tricky, x minus 3. If you just put x minus 3 like this, you might forget something. Make sure it's in parentheses. X minus 3. Okay, now look what we have here. We got the same base. 2 to some power equals 2 to some power. That's what we want. Alright, if I had 3 to the x equals 3 to the 5th, right? X would have to equal, this would have to be 5 for these two things to be equal. Right? Same thing here. 2 to some exponent equals 2 to some exponent. These two exponents have to be the same. So therefore, let's rewrite it. 2 to the 2x is equal to 2 to the, if I multiply this, negative x, multiply this, plus 3. So therefore, look at that. 2 to some power equals 2 to some power. These two powers have to be the same if this equation is equal to each other, right? So all we do now is do this. 2x has to equal, this exponent has to equal this one, negative x plus 3, which means all you got to do now is solve. Plus x on both sides, 3x equals, 3 is left over, which means x equals 1. There you went. There you go. You solved. If x was 1, these two things would be equal to each other. Okay? That's it. Solved by equating exponents. So basically, it's like there's an art to this. Make both of these the same exact base if you can. Now, if you can't, that's something different. All right. All right. Example number 2. Here's an example where you can't get them to the same base. Like you have 4 and you have 11. You can't break down 11 to make it 4 or 2 or anything like that. So therefore, you only have really one option. What we want to do, what do we want to do? Our goal is to get x by itself, right? That's always our goal. Get x by itself. Which means we'd have to get rid of 4. A base of 4. Now you remember all this stuff about logarithms, exponential, they're inverses of each other. So how do you get rid of a base of 4? You take the logarithm of each side. Okay, we've done that before on a different type of example. How to get rid of base 4? You log both sides. So we log this side, okay, log base 4 because we want to get rid of base 4 to the power of x equals log this side right here, log base 4 of 11. Notice what I did. I just added a log. I didn't really add it to both sides, but I put log on both sides. Log of this side equals log of this side right here. There you go. Now look at this. This is going to simplify. This is going to cancel out a few things. Log base 4 of 4 is really 1. Kind of cancels out. 1 times x is just x. Equals you can't simplify this, right, by hand anyway. You can get a decimal, which is what we're going to do. Log base 4 of 11. 4 to some power equals 11. Can't do that in your head. So type this in your calculator. Using, how are we going to type that in our calculator? Using the change of base formula, right? So x equals log of 11, log of this guy, divided by log of this guy, log of 4. So type this in your calculator, and you got your answer. X equals blank. Answer is about 1.73. So you can see what the book does. Book did it exactly as I did it. It shows you the steps here. Maybe you'd like to see that. So there's example 2. Basically, what's the difference between example 2 and example 1? You couldn't get this side and this side to be the same base. Because if you could say, oh, base 2 squared to the 2x equals, get this to base 2, which you can't. Oh, those bases are the same. Let's say it was 2 to the first. Oh, that means the exponents are the same. So 2x equals 1, x is 1/2. So example 1 is like this. But example 2, you can't get them to the same base, so therefore you have to log both sides. Alright? Only if it's an exponential equation do we log both sides, because that's the opposite. But if it's a log equation, we're going to do something else. So, that's example 2.